Now we're going to look at a type of confidence interval problem where sigma is unknown, which we've seen that kind of problem before, but what you're given is raw data. Let's take a look at this question. So the grade point averages, GPA for 12 randomly selected college students are shown to the right here. So complete these questions. So first we're going to find the sample mean. Notice that in previous problems, the sample mean, and then also part B, find the sample standard deviation. In previous problems, those were given. What we have right now is raw data. We actually have to figure out what that is. So in the software, if you can, see this little rectangle, click on that, and if you click on that, the data will pop up in your software. You might be using Excel. I'm using LibreOffice. They look about the same. So from this, we can calculate the sample mean. You just type equals average, open parenthesis, and then highlight your data to get the cell names right, close parenthesis, enter, and your mean has been calculated for you. Next, equals, and next I should say we're going to calculate the sample standard deviation. So equals STDEV, that's the command for that. Open parenthesis, highlight your data, close parenthesis, hit enter, and there is your sample standard deviation. So we're going to take that information and we're just going to jot it down. So sample mean, okay, sample mean X bar was 2.3, and the sample standard deviation S was, let me check that again, 1.1901. 4 decimal places should be good enough there. Okay. And now we're ready to do the problem the way that we normally do. We're ready to construct the confidence interval by our usual method. So we know that a confidence interval, I should say confidence interval for mu, and again we know that because we don't have sigma, we'll be using S, which also means we're using the t-distribution. So the formula for the confidence interval is going to be X bar plus or minus t times S for X bar. So we already know X bar. We just calculated it. That's 2.3. And SX bar, we don't know it, but we can figure it out pretty quick. That is 1.1901, or let me write down the whole formula. S over rad n, which is 1.1901, divided by the square root of, quickly count up, I see that it's 12. So let me actually just jot that so I remember that. N equals 12. And now I'm just going to punch that into my calculator. So I'm going to use this for my calculator. 0.1901 divided by the square root of 12. Okay, so 0.3436 if I'm rounding. So there's my S for X bar, and that's another thing that I needed for the formula. Okay. And then finally, we have to find T. So to find T, we go into StatDisk. There's other technology that you can use. My favorite is StatDisk. So click Analysis, Distribution, Student T Distribution, and now we need to fill this in. So since we know that n is 12 degrees of freedom, let me actually just jot this down over here. Degrees of freedom is n minus 1, so that's going to be 11. Okay. So degrees of freedom is 11, and we're trying to find the t-value, so that means we have to know what is the area to the right of the t-score. So it is a confidence interval, which means our picture has two tails, and it is a 95% confidence interval. So 0.95 is in the middle, and that means 0.025 is in each tail. So the area to the right of my t-score is 0.025. Click evaluate, and there's the t-score. It's 2.2. I guess if I go to 3 decimal places, it's 2.201 if I round it. So using StatDisk, there's the t-score. And then the rest is just a quick arithmetic calculation. So let's figure this out. So 2.201 times 0.3436. Okay. So that gives me 0.7563 if I'm rounding. Actually, let's see. I think typically it says round to 3 decimal places, so we're going to round the answer to 3 decimal places. There you go. And now we just do the plus minus. So 2.3 minus 0.756, and then 2.3 plus 0.756. And that gives you your confidence interval. 1.544 and 3.056. So here I rounded to 3 decimal places. I think that's typical. Of course, you can round to however many places you want, or however many is requested for the particular problem.